Hi everyone, today we'll be talking about vectors. Vectors are quantities that have both magnitude and direction, such as velocity and acceleration. This is different from scalars, where they only have magnitude. An example of a scalar is mass, as it only has a magnitude and no direction. Vectors are represented on graphs by drawing an arrow connecting 2 points. To add vectors, one of the easiest ways is to use the tip-to-tail method. With this method, you'll connect the starting and end points of the vectors, and the resultant is the sum of the two vectors. When multiplying a vector by a number, it works the same as multiplying a scalar by a number. So basically, it increases or decreases according to how much it is multiplied by. In physics, vectors are used in a wide variety of subjects. Typically, a problem will primarily be that a variable is given in a certain direction, and you need to use trigonometry to solve for different components of that vector. We'll see this in the upcoming example. Lastly, the general sign convention is that north and east are positive, and south and west are negative, as that represents the sign convention used on a typical Cartesian grid. Now let's go over an example. A plane is flying due north at a speed of 300 kilometers an hour. However, there is a wind blowing from the west at 50 kilometers an hour. Determine the resultant velocity of the plane and its direction. Let's start by writing down the variables that we know, and we can draw the problem out. The plane is moving at 300 kilometers an hour north, or in the positive y direction, and 50 kilometers east, or in the positive x direction. As seen on the diagram, if we solve for the resultant of this triangle, we will find the resultant velocity of the plane. To find the resultant, we will use basic trigonometry to find the hypotenuse of a right triangle. This is the square root of the x component squared and the y component squared. And this is equal to the square root of 50 squared plus 300 squared. We find that the resultant velocity is 304.1 kilometers an hour. Now we need to find the direction that it is traveling in. By using SOHCAHTOA, we see that the angle can be found using the inverse of tan of the x velocity divided by the y velocity. This is equal to the inverse tan of 50 divided by 300. And we find that the angle is equal to 9.46 degrees. Now we need to write out the direction. We can see from the diagram that the plane is moving east of north, so the final answer is that the plane is traveling 304.1 kilometers an hour at 9.46 degrees east of north.